Welcome back to Mastering MHA MBA. This is Chapter 10 of Managerial Accounting, Part 3 of 4, based on Managerial Accounting by Datar and Rajan from Pearson. Parts 1 and 2 covered quality. Now we turn to inventory. How much to order, when to order it, and why the last few years rewrote the answer. For 40 years, the textbook said the same thing: hold as little inventory as possible. Then a pandemic, a blocked canal, and a global chip shortage taught every supply chain manager the same expensive lesson in empty shelves and idled car plants. Here is the thing though: the math in this part did not break, the inputs did. Learn the model properly and you will understand exactly what changed and by how much. Inventory decisions juggle 5 cost categories. Ordering costs come from preparing purchase orders, receiving, and paying. Carrying costs are the price of holding goods. Capital tied up, warehousing, insurance, obsolescence. Stockout costs hit when you run out. Lost sales, lost customers, emergency expediting. And then quality costs and shrinkage, which is theft and damage. Every inventory policy you will ever see is some trade-off among these 5. The economic order quantity model answers one question: how many units per order? The formula is the square root of 2dp over c, where D is annual demand, P is the relevant cost per order, and C is the relevant carrying cost per unit per year. You do not need the calculus. You need the intuition. Total cost is minimized where annual ordering costs equal annual carrying costs. Order bigger and you order less often but carry more. Order smaller and you carry less but order constantly. EOQ is the balance point. Now read the fine print because it is about to matter. The simple EOQ model assumes demand, ordering costs, and carrying costs are known with certainty. The purchase order lead time is known with certainty. Purchase price does not depend on order size, and stockouts never happen. Every one of those assumptions is a place where the real world can, and recently did, punch through the model. The second question is when to order. The reorder point is units sold per period times the purchase order lead time. The textbook stays with Photon, which uses 20,000 copier frames a year, about 385 per week. Lead time is 2 weeks, so the reorder point is 385 times 2, 770 frames. When stock falls to 770, Photon places its EOQ order of 1,000, and the new frames arrive just as the bin empties. In theory. Because demand spikes and deliveries run late. Safety stock is inventory held at all times on top of the EOQ cycle as a buffer against unexpected demand, lead time surprises, and supplier shortfalls. How much depends on the probability of those events and the cost of a stockout when they happen. Hold that sentence in your head. The size of the buffer scales with uncertainty. It becomes the key to everything after 2020. One more textbook insight that separates A students from the rest. The EOQ model counts the opportunity cost of capital tied up in inventory. The accounting ledger records no such expense. So a manager evaluated purely on reported costs sees carrying inventory as cheaper than the model says it is and orders more than the optimum. The fix is to evaluate managers on the same relevant costs the model uses. Misaligned incentives quietly corrupt even perfect math. Now push the model to its limit. Just-in-time purchasing means buying in small batches timed exactly to need. Look at the formula. As ordering cost P falls, the optimal order size falls with it. So companies attack P: long-term agreements, electronic ordering, suppliers delivering straight to the production floor. The textbook example is Hewlett-Packard's printer plants, where suppliers deliver small orders directly against the production schedule and are evaluated on delivery timing and quality, not just price. When P gets small enough, the EOQ logic itself says order tiny and order often. And that was the state of the art until the world started moving every input at once. 4 updates. Watch the variables, not the headlines. Lead time, stockout cost, price, and demand. After the pandemic disruptions, McKinsey surveyed about 100 supply chain leaders. 78% had increased inventory buffers. 78% had moved to dual sourcing for critical materials, and 64% were regionalizing their supply chains, up sharply in 1 year. This is not the death of just-in-time. It is safety stock logic applied honestly. Stockout costs turned out to be far higher than anyone had priced in. Even Toyota, the inventor of just in time, quietly keeps months of chip inventory under a continuity plan dating to the 2011 earthquake. The buffer scales with uncertainty, exactly as the textbook said. Remember the reorder point formula: units per period times lead time. In early 2024, attacks on Red Sea shipping pushed carriers handling roughly 30% of global container trade off the Suez route, adding 4,000 miles and 10 to 14 days of transit. Spot rates on Asia to Europe lanes rose nearly fivefold. Every reorder point on that lane was wrong overnight, and every safety stock had to be resized. One geopolitical event, straight through the L in the formula. The simple EOQ model assumes purchase price does not depend on timing. 2025 broke that assumption. Ahead of new United States tariffs, companies front loaded imports and stockpiled inventory, and the Port of Los Angeles logged its second best February on record. That is a pure relevant cost play. Accept higher carrying costs now to avoid higher purchase prices later. By mid year, those buffers were running dry and the trade off flipped back. Whatever your politics, the accounting is the same. When prices move, timing becomes part of the inventory decision. Last update, and the most hopeful one. Safety stock exists because demand is uncertain. IKEA spent 3 years building an AI demand sensing tool that ingests short term signals: local weather, market events, campaigns, pricing. In its Portugal rollout, it measured about a 5% improvement in forecast accuracy. 5% sounds small, but every point of forecast accuracy lets you carry less buffer for the same protection. The D in the formula is becoming a live prediction instead of an annual constant. You now have the buying side: order size, reorder timing, buffers, and what the last few years did to each. Part 4 moves inside the factory. Just-in-time production, the ERP systems that coordinate it, and the final topic of the chapter: time itself as a competitive weapon. See you in part 4.